Here we have a rather typical exponential equation that appears early in this chapter. Solve 9 raised to the 2x plus 1 equals 27 raised to the 1 minus 3x. And what allows us to be able to solve this exponential equation is the fact that the bases, 9 and 27, are both powers of a common number, 3. Now, if the bases were not, a common power of a common base, for example, if this was a 7 and this was a 13, we'd be out of luck right now. But we can solve those. We'll solve those types in a later section after you learn about logarithms. But for right now, let's go ahead and solve it directly. And 9 is 3 to the second power, and 27 is 3 to the third power. So by using 3 as our common base, we can reorganize this equation. So I'll rewrite 9 as 3 squared raised to the 2x plus 1, and 27 is 3 cubed. That's raised to 1 minus 3x. And let's take out the parentheses. When you do that, the power rule says we're going to multiply exponents. So in other words, this is 3 raised to the 2 parentheses 2x plus 1, and 3 raised to the 3 times parentheses 1 minus 3x. So we can go ahead and multiply through there. This is 3 to the 4x plus 2, and 3 to the 3 minus 9x. But now we come to the point of the problem. We have a common base. 3 raised to the power equals 3 raised to the power. Does it make sense that if the bases are equal, then the exponents are equal? Of course they are. So I can now ignore the 3, the base 3, and we have 4x plus 2 equals 3 minus 9x. So that way, by rearranging this as we did, it boiled down to, in this case, a simple simple linear equation. If I add 9x to both sides and subtract 2, we'll get 13x equals to 1. So it looks like x equals to 1/13. All right, so it's not hard to check that. You could check it manually by putting 1/13 up into here, and I suspect you'll have to pull this again, bring it down to powers of 3. It'll work. You can also just use your calculator and see if the left side is about equal to the right side. So yeah, it's possible to check these. All right, I'm going to erase this and put up one more of these. Now let's solve this exponential equation. 16 raised to the x plus 2 equals 1/4 raised to the 5 minus 2x. All right, so first thing we should look for is, do we have a power common base that we could use? 16 is 2 to the 4th power, and 4 is 2 to the 2nd power. So 2 is a candidate, but also we could use 4 because 16 is 4 squared. So how about we go with 4? 16 is 4 to the 2nd power, and this will be raised to the x plus 2. And on the right side, 1/4 is 4 to the negative 1 power. So I wanted to get a problem in with the negative exponent here because some students are kind of rusty at negative exponents at this point in the course. All right, so again, I'm going to multiply the exponents out. We've got 4 to the 2x plus 4 equals 4 to the negative 5 plus 2x. So the power rule says again that we can multiply exponents when we take the parentheses out. And here we go. We have a common base on both sides. So now I can just make the exponents equal to each other. So 2x plus 4 equals minus 5 plus 2x. And, oh, well, this is interesting. I didn't expect this to happen. This rarely happens, but sometimes when you just make things up, it will. When I subtract 2x from both sides, I'll get 4 equals to minus 5. All right, so there's no answer to this problem. No solution. No solution. All right, well, please don't, you're not going to see that, I don't think, in our textbook, and you won't see it probably on any of my tests. But, I guess it could happen, and here's a problem with no solution. That's an exponential equation. All right, well, but anyway, the same idea holds here. Normally you would just solve this and get an answer. And so in this case, we couldn't get an answer. So, all right, well, time to move on.